Okay, so we're going to work with the derivatives of the trig functions in this section. And I invite you to use the QR code or the links on the PDF if you're on WebAssign or if you're on D2L to access this web page. And we're going to start with trying to find the derivative of the sine function. Now, what I'd like you to do first is look at your graph and mark the places where the derivative would be zero. So put a zero, you're going to graph zero on the x-axis, but wherever there's a place where the derivative of this function is going to be zero, put a little dot there on the x-axis. So we're going to try and see if we can't create for ourselves what that derivative function has to be. So where does this function have a derivative of zero? Remember, the derivative is the instantaneous rate of change. So you want that instantaneous rate of change to be nothing, to be flat. So where are you going to have a horizontal tangent line to this graph? Now, while you're doing that, I'm going to clean this up a little bit. Actually, it's already. It's kind of funny. So places where its derivatives are zero. Now, if you're actually on the website, then you can click here. And it should put some points on the x-axis at odd multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, etc. That's where you're going to have a derivative equal to 0. Now let's move up to a different one. Try and decide where the derivative is going to be 1. And let me try and spread things out a little bit on the x-axis. The slope of the derivative is going to be 1 right about here. All right, where its rate of increase is equal, in both directions, up and over. So about there. So I'll put a 1 at the top here. And then, am I going to put a 1 for the slope of the tangent line at pi or negative pi? Well, what's the slope of the tangent line going to be like there? Is it going to be positive or negative? Right at negative pi. Yeah, it's going to be negative. So slope should be negative there, positive over here, and so on. So at multiples of pi, you're going to see the derivative either at 1 or negative 1. So I'll give you a moment to fill those in. All right. So if you're filling those in, it should look like this. And let me put these in a different color here. At negative pi, the derivative should be negative 1. At 0, the derivative is going to be 1. And then the next one over here, negative 1, and so on. And let's see, can I get one more here? Yeah, over here, like that. Now that's starting to trace out a function. So let me fill those in over here. Places where the derivative is 1 or negative 1 is going to look like that. And if you're trying to figure out, well, what's that function look like in between, then we can click this last button here. So you get that blue graph. Does anyone recognize that blue graph? Yeah, that blue graph is going to be your cosine function. So the derivative of sine, now this isn't a real proof. This is just kind of hinting at it, but it does give you cause to believe that the derivative of sine is cosine. So yay. Let's do this. Sine of x prime is cosine of x. Now, what would you guess cosine of x prime is? Yes. Oh, real good, real good. Yeah, it'd be nice, the lion and the lamb would be best friend, there'd be peace in the Middle East if derivative of cosine was sine, but it's not. It's negative sine. It's so annoying. Yeah, I get it. And derivative of tangent. Well, let's actually do that one together. Let's figure that one out. And this is how we're going to do it. Tangent of x is sine of x over cosine of x. What do I have to do to find the derivative of sine of x over cosine of x? What rule do I have to use? I think, is it Jackson? Say again? What rule do I have to use here? Yeah, use the quotient rule. All right, so derivative of tangent of x prime is going to be the square of the denominator. So cosine of x squared. And then what? Alexandra, what should I start out with up here? So square of the denominator, and then the denominator times the derivative of the numerator. So what's the derivative of the numerator here? Cosine x. Awesome. Minus the derivative of the denominator, and let's be careful here. Derivative of cosine of x is, it's not sine of x. Yeah, thank you. Negative sine of x times the numerator, which is sine of x. Nice. Now let's clean this up a little bit because we can. You get cosine of x times cosine of x. Let's write that as cosine squared of x. A minus and a minus becomes a plus, sine squared of x over cosine squared of x. Can I clean it up anymore? Yeah, it's 1 over cosine squared of x. And let me remind you, 1 over cosine of x is really secant of x. Or better yet, secant squared of x. And I actually took the time to write secant squared in a couple different ways. That's something that I want to remind you of in your trig notation. This and this are the same. So this is really cosine of x times cosine of x. That leads to a lot of problems when people aren't careful later on. But the bottom line is that the derivative of tangent is secant squared, which is wow. It's like bizarre. It's like, really? Yes, it is. Derivative of tangent is secant squared of x. And let's see what else here. Then we've got the cosecant of x, the secant of x, and the cotangent of x. And I'm hoping I left myself enough room to write their derivatives here. Let's see if I can't squeeze those in. Derivative of secant is the secant times the tangent. Derivative of the cosecant is minus cosecant times cotangent. And the derivative of the cotangent is minus cosecant squared. Yeah, I think I should do that. Prime, prime, prime. Thank you. Yes. So there's your 6 basic trig derivatives. I would suggest you have these things memorized. Now, I tend not to use these so much, but it's convenient to have these memorized anyways. These you should definitely know. You know, if I give you something like derivative of cosecant and you're like, I don't remember what it is, you could always write the cosecant as 1 over the sine of x and then differentiate with the quotient rule. And that's fine. It'll lead you right to this conclusion. So if you forget some of these, you know, you're not in critical shape. But these first 2, you definitely got to have memorized. Now, there's one other thing that I want to point out here, little memory trick. If you notice this one, and this one, When you differentiate these things, they all had a negative in them, right? All of them had a negative. What's in common to all of these? If it starts with a C, the derivative is going to have a negative. Cosine, derivative is negative sine. Cosecant, have a negative here. Cotangent, you have a negative here. That negative is going to be really annoying. So if you can remember that, and that's why I take the time to talk about this little trick here. If you can remember that, it's going to help you out. It really will. All right, so let's take a look at some of these problems. Let's start out with example A, and I'm trying to think here. So let's just label this one 16. Example A. So the cool thing is that in teaching math, I've learned like tons of my Greek letters. Here we've got h of theta equals theta squared times sine of theta. And the question is to find h prime of theta. So h prime of theta. So what are your thoughts? What do you have to do when you differentiate this? Product rule, absolutely. So it's not necessarily easy to see. I mean, this looks like such an innocent function, but really that's your u times v. And we need to do this with u prime v plus v prime times u. So let's work on that. H prime can equal u prime times v plus v prime times u. I don't know if you need to continue to write these out. If we did u equals theta squared, then what would u prime be? Differentiating with respect to theta, of course. Alexandra, what would u prime be? 2 theta. Good. And then v is sine of theta. And that means the derivative v prime is going to be cosine of theta. And thanks, Alexandra. All right, let's put this together. U prime times v plus v prime times u. H prime is going to equal, let's see, it's going to be 2 theta times sine of theta plus theta squared times cosine of theta. Or I guess if I'm writing it this way, v prime times u, cosine of theta times theta squared. I don't like writing the theta squared there. I'd rather write it here, because if I write this theta squared there, something's going to give me cosine of theta cubed. Right? You can't multiply what's here with what's there. But that's it. There you go. There's your derivative. Nice. All right. Let's keep going with some more derivatives that involve our trig functions. See, example B. Oh, okay. Here we go. Example B. Y equals 2x over 7 minus the tangent of x. Okay. Javier, what rule am I going to have to use to differentiate this? Yeah, the quotient rule. Awesome. Thank you. So let's see. You know, in these early chapters, you know, I'm going to, for a while, I'm going to write things out. I'll call that f is 2x, g is 7 minus tangent of x. I'm going to need f prime and G prime. Austin, what's going to be F prime and G prime, please? Good. That's going to be a 0 when you differentiate that. Perfect. And the minus there is going to be there still. So it's going to be minus secant squared because that's kind of like a constant. So perfect. Thank you, Austin. Let's see. Well, let's fill it in and write out G prime or Y prime. By the way, different notation for Y prime would be dy by dx. Or if I call that f of x, then I could call this f prime of x. Sometimes I'll just call it f prime, and the of x is implied. But there's a lot of different notations for the derivative. It gets a little annoying and confusing sometimes. I apologize in advance, but don't shoot the messenger. Let's think. So all of that is going to start out with the square of the denominator, so 7 minus tangent of x squared, and then the denominator times the derivative of the numerator, times 2, minus the numerator times the derivative of the denominator, which is going to be minus secant squared of x. Now, I'll tell you up front, I don't think this one's going to simplify much at all. Although I would appreciate it if you would distribute a couple things, like, for instance, distribute the 2 to both of those terms up front. So I'll distribute here and here. And then to kind of get done with this thing in a little bit more of a hurry, I'm going to distribute, well, I guess it's just multiply the negative 2x times that term there. So overall, it's going to be 14 minus 2 tangent of x plus 2x secant of x squared over 7 minus tangent of x squared. You'll rarely see me square out the denominator unless there's some compelling need for it. Just leave it. All right. Let's move on to example C. And I'm trying to think what I want to number this. I guess this would be page 17. Example C. Example C. F of x equals 3 to the x cosine of x. I want to find the equation of the tangent line at x equals 0. Find the equation, I'm just going to be lazy and abbreviate it EQN, of the tangent line. So once again, I'm trying to show you what to expect on an exam. On an exam, I expect that you can find the y coordinate of the point of tangency. So it's simply going to be plugging in 0. So f of 0 would be 3 e to the 0 cosine of 0. What does that all work out to be? Yeah, I'm sure you guys got e to the 0, that's just 1. But how about cosine of 0? What's cosine of 0? Oh man, now I'm testing you, right? It's like, oh, trig feels like a million years ago. Yeah, it's 1. Remember, you're looking at the x coordinate of your point on the unit circle. The x coordinate at 0 is 1. So that's just going to be 3. So I've got the point 1, 3. It's going to be 0, 3. 0, 3. And now I need to find the slope of the tangent line. So, Diana, what do I need to do to find the slope of the tangent line? In general terms, you don't have to give me specifics here. In general, what do I got to do here? Find the slope of the tangent line. Say again. I need something first though before I put in the slope intercept form. Yeah, I need the prime. I need the derivative. Good. So let's see. F of x is 3e to the x times cosine of x. What do I have to do to find the derivative there? Yeah, the product rule. So let's see. F prime of x, I'm going to regard it as a product of two things. Now you got to put that constant with one of them. So I'm going to put that constant with that first term. And then cosine of x is going to be the second one. So it's going to be derivative of the first. Derivative of 3dx is just going to be 3e to the x. So 3e to the x times cosine of x plus the derivative of the second times the first. What's the derivative of cosine? Negative sine of x. And if I factor out the 3e to the x, I'm left with cosine of x minus sine of x. Now, I don't necessarily need to factor that out in order to find the slope of the tangent line. It doesn't really come into play so much, but f prime of 0 is going to be 3e to the 0 times cosine of 0 minus sine of 0. Sine of 0 is 0. So that's kind of nice. We get rid of that. That's 0. That's a 1. So what's the slope of the tangent line? 3 times 1 times 1. 3. That's our slope of the tangent line. The last little bit here is to figure out what the equation of the tangent line is. We got the slope. So it's this y minus y1 equals m times x minus x1. So it's going to be y minus 3 equals 3 times x minus 0, which is going to be y equals 3x plus 3. Okay, done. How we looking on that one? That one okay? I don't remember if I did that one up on decimals or not. Let's take a quick peek. Let's do it this way. 3 point. I don't see any graphs for 3.3. All right. Let's just do this. I want to check it. And you can check it yourself. You want to check it on Desmos or the graphing calculator? Let's do the graphing calculator just for giggles and for practice. So let me clear out a few things here. And then start by typing in the function. So I'll clear out all this. Let's type in 3e to the x cosine of x. So 3 second ln gives me my e to the x power. Press the right arrow to exit the exponent, followed by cosine of x. And then press enter. Now, as it stands, if I try to do this right now, if I try to find the, or show that the graph of the tangent line actually did touch it very nicely at that one point, it wouldn't work on my graphing calculator. There's something that's wrong. Let's see, the equation of the tangent line was 3x plus 3. But if I graphed it now, it wouldn't work. Can anyone tell me why? What's wrong? Calculus is done in radians. Yeah, right now my calculator is in degree mode. All right, so what you'd have to do first, as soon as you notice that, go back and put it over into radians. This course is going to be done completely in radians. If you wanted to use degrees, it would mess up all our formulas. If you're using degrees, then the derivative of sine would no longer just be cosine. It'd be cosine times pi divided by 180. And you'd have all that, the ugly constants involved for everything else too. Now, since I want to see the derivative near 0, I'm just going to choose a small window with 0 at the center. So -2 to 2. And I'm not going to bother hitting zoom 0. Let me just do my own here. Let's just go from -5 to 5. That should be good enough. It's actually probably overkill, I'm guessing, but we'll see. And now I can hit the graph key. And bam. So our tangent line looks like it hits pretty dead on at 0. In fact, if you hit the trace key, here I am on the function. That's why it's blue. But if I hit the down arrow, now I'm on the tangent line. And notice that they're the same point. If I move over a little bit, it'll no longer be the same point. It'll be close. If I go up, down, it's off by just the smallest amount, but it's close. So if you see something like that, you can feel really good about your work. Probably have done it right. Let's keep going. Find the equation of the tangent line to the curve at the point pi over 2 and 3 pi. I don't know why it keeps on changing my view. I'm actually backing out of this program altogether, but whatever. Again, you've got to use the quotient rule, or the product rule. So there's your u and there's your v. U equals 6x, v equals sine of x, u prime equals 6, v prime equals cosine of x. So if I wanted to calculate the derivative, that's going to be y prime equals u prime times v, so 6 sine of x, plus v prime times u, plus cosine of x times 6x. Now, like I said, I get nervous sometimes when people do this because there's this overwhelming temptation to say, oh, well, 6x, it's going to be cosine of 6x squared or something like that. You can't. Might as well just write that out in front. In fact, and speaking of writing things out in front, I'm going to factor the 6 all the way out in front. 6 times sine of x plus x times cosine of x. Beautiful. So that's a cleaned up version of the derivative. Let's see about finding the slope of the tangent line. Slope of the tangent line is going to be what happens when I plug in pi over 2 into this. So I'll end up with 6 times sine of pi over 2 is 1. And cosine of pi over 2 is going to be mercifully 0. So that's the slope of my tangent line. Now the equation of the tangent line is going to be a little bit messy because they're not exactly nice points, but that's okay. Here's your x1, y1, and that's your slope. So y minus y1 equals m times x minus x1. It's going to be y minus 3 pi over 2, or it's going to be 3 pi, I should say, equals 6 times x minus pi over 2. And this is going to work out pretty special. Y minus 3 pi equals 6x minus 3 pi, or y equals 6x. That's your equation of the tangent line. Yay. Is there anyone interested in graphing this and double checking it, or are we good here? Just move on. All right. Let's see. Let's move down to example E, this one. And I think I want to move over to a new sheet of paper for that one. Now, I've already done something like this earlier today. F of x is tangent of x minus 1 over secant of x. And as kind of a quick reminder, what I did earlier was I differentiated things two ways. One by using the quotient rule and one by being a little bit more clever. So here was the quotient rule for finding the derivative of this function. And that was just a whole lot of fun, probably about 10 minutes worth of fun and a lot of awful calculations. But here's the other trick where I divided each term in the numerator by the term in the denominator. And the thing that was nice is I got some simplification and I got a nice friendly expression from which I could find the derivative. And so it's up to you if you want to take the time at home at some point to differentiate this using the quotient rule, you can. But let me do this without the quotient rule. And for that, I'm going to write it as tangent of x over secant of x minus 1 over secant of x. Now, in doing some of these things, it might be helpful to remember the basic definitions in terms of sines and cosines. What's the definition of a secant in terms of sines and cosines? Anyone remember? Secant is a reciprocal of the cosine of x. Tangent is what over what in terms of sines and cosines? Yeah, sine over cosine. Minus 1 divided by 1 over cosine of x. Now let's simplify this. This is really the reciprocal over reciprocal. So this over here is just cosine of x. And over here, when you divide by a fraction, the trick is to invert and multiply. But I'll give you a little shortcut. Here, I'll show you how it would work, how it looks. So divide by a fraction to be the same as multiplying the numerator sine of x over cosine of x times the reciprocal of the denominator, cosine of x over 1. Now, in both cases, here and here, you're getting some cancellation. So in this kind of a situation, if you see the denominators are the same, they'll just cancel them right there. And so what's that leaving me with? It leaves me with sine of x over 1, or how about just sine of x? Now, it did take us a couple seconds to do it this way. But is there anyone that doubts me when I say that doing this with the quotient rule would be a lot harder? Now, all right, so good. Because otherwise I was going to say, all right, for homework, go ahead and prove it. So smart of you to not in agreement. Now, we haven't taken the derivative yet, right? All we did was we simplified this. So please don't get too excited. We still got to calculate the derivative, but I think the derivative here is going to be a lot easier to calculate here than it would be up here. So let's see here. We haven't called on yet in a while. Jackson, you're up. What's the derivative going to be there, please? Derivative of sine is cosine minus derivative of cosine, which is negative sine. And I do expect that you clean that up a little bit. Negative is a positive, but there. Awesome. Awesome. Hey, I think we need some love on that one.
That was easy.
Yeah, not so bad after you cleaned it up a little bit. All right, so kind of giving some strong hints that you can make your life easier on certain problems. And if you can, that's great. I'm not going to ask you to do it the long way if there's a nice shortcut that's available. Okay. Let's keep going. So example F. Y equals 3x plus 7 times cosine of x. We want to find the equation of the tangent line at x equals 0. All right, so Nicole, what are we going to have to do to get started here? Trying to find the equation of the tangent line. There's really a couple ways you can start. What do you see? What works for you?
Do you want to find the y coordinate?
Yeah, let's find the y coordinate. Sure. So I'll call it y of 0 equals 3 times 0 plus 7 times the cosine of 0, which is 0 plus 7, or just 7. So yeah, thanks, Nicole. So we've got a point at 0 and 7. That's where we want to find the equation of the tangent line. So then what? Let me go back up to the top. Chris, what's next? Yeah, find the derivative. So some help in finding the derivative. Anyone? Ryan? What's the derivative going to be, please?
3 plus negative sine x.
Perfect. Now I'll just take that negative and factor it out there. So 3 minus 7 sine of x. But yeah, 3 plus negative 7 sine of x. Both of them work. That's great. Awesome. Thank you, gentlemen. So y prime, Rohan, what's y prime going to equal for us? Sine of 0 is 0. So y prime is going to be 3. That's also the slope of your tangent line. So is the function increasing or decreasing at that point? If I was to actually look at the graph of 3x plus 7 cosine of x, would the function be increasing or decreasing? Be increasing because the derivative is positive, right? And where the function is increasing, you're going to have a positive slope to the tangent line. Now, as far as the equation of the tangent line, let's do that. Y minus y1 equals m times x minus x1. So here's your x1, y1, and here's your slope. So y minus y1 equals m times x minus x1. Let's put everything in. Y minus 7 equals 3 times x minus 0. When you solve for y, you'll end up with y equals 3x plus 7. Sweet. And again, there's nothing wrong with double checking these things by graphing them on your graphing calculator and making sure that both of those things line up. This can be a really big PDF when I scan in the notes today. Really big. All right, comments on that last one? Let's keep going. Here's kind of a cute one. I'm gonna go through this one a little fast because I want to spend a little time on example I. I don't know if I'll get to example G or example J, but f of x is a secant of x, and I want you to find f double prime at pi over 4. So f prime of x. Now, I don't expect you to have these memorized yet. F prime of x, oh, I guess should probably have a t. I'm just going to keep going with x though. There's going to be the secant of x times the tangent of x. So, okay. But they want f double prime here. So what that means is I got to differentiate this thing yet again, which is annoying for two reasons. One, I already did a derivative, and two, differentiating this is not going to necessarily be finding the derivative of secant times the derivative of tangent. What do I have to do to find the derivative of this expression? Yeah, got to use a product rule. Perfect. So let's use a product rule on that. I'm just going to kind of sneak things in this way. I'll call that my u, and I'll call that my v. F double prime of x is going to be u prime times v plus v prime times u. So let's see if we can't do that. U prime is going to be secant of x times tangent of x. Secant of x, tangent of x. That's my u prime times v. So I got another tangent there. That's okay. Plus v prime. Does anyone remember what the derivative of the tangent was? Yeah, secant squared of x. So it's going to be v prime times u, which is secant of x. Now I can clean that up a little bit. Let me do that. That's going to give me f double prime of x equals secant times tangent squared, secant of x times tangent squared, plus secant cubed of x. Crazy. All right. Last but not least, I got to substitute in pi over 4. F double prime of pi over 4 is going to be secant of pi over 4 times tangent squared of pi over 4 plus secant cubed of pi over 4. Let's start out with the secant of pi over 4. Secant is going to be the reciprocal of what function? Going to be the reciprocal of the cosine. Now, if you're looking at that going, man, I just don't remember secants that well. Hey, I get it. I understand. So let's take a look at it maybe on the graphing calculator real quick. See if we can't jog our memory. So secant is the reciprocal of the cosine. That is something that you're going to have to make sure you know. But when you go to cosine of pi over 4, you're going to get a number that you might not really recognize. And then you're like, ah. So yeah, let me hit the square button here. If I squared that, you get 1/2. So what it started out as is the square root of 2 over 2. Well, we got the reciprocal of that. If I take the reciprocal of this, then maybe you'll get a number that you do recognize. So I'll do, let's go up here, 1 divided by, can I do this? Yeah, 1 divided by that. If I hit the square key now, maybe recognize that as the square root of 2. So coming back over to here, let's fill in a couple things. That's going to be square root of 2. Tangent of pi over 4 is going to be 1. And that's going to be square root of 2 cubed here. And I guess you could clean it up a little bit. There's not a lot that's going to clean up. Actually, you know what? It does clean up pretty nice. There should be a plus between these things. If I factor out the square root of 2, I can clean it up pretty nice. Bless you. So let me do that. Now, I'm not going to necessarily always expect you to get every last little thing here. If you got square root of 2 plus square root of 2 cubed, I'd probably give you full credit. But if you went a little farther and said, oh, well, there's a common factor of the square root of 2, and it leaves behind 1 plus square root of 2 squared, I hope that you can simplify it from here. What happens to the square root of 2 squared? So this is really 3 times the square root of 2. Would be your final answer there. Like I said, I'm not going to go overboard on you in terms of knowing all this stuff, but I hope that you do remember some of your trig values, or can at least get them off your calculator. All right. The last one that I want to do, I'm actually going to, let's see here. I don't want to do this one. With what we know right now, there's not much you can do to differentiate this other than write it as cosine of t times cosine of t. Eventually, we'll learn some tricks to do this in a different way. But when you square something, Rohan, you're really just multiplying it by itself. So I can write it like this, and then I can use the derivative. You can use the product rule to finish differentiating this. So let's see what we get. It's not going to be something that you might have been able to expect. So let's see, we've got u is cosine of v, or cosine of t. V is cosine of t. What's the derivative going to be? Negative sine. Thank you. Negative sine and negative sine. So I want u prime times v plus v prime times u. So h prime of t is going to be, let's see, minus sine of t times cosine of t plus minus sine of t times cosine of t. It would be nice if you clean this up a little bit. Does anyone see how this is going to clean up? So I've got negative one of them here and negative one of them here. But if you look at the rest of this is like terms, right? This and this are the same. So negative 1 and negative 1 give me negative 2 sine of t cosine of t. And that's what I'd like as your final answer on something like that. Sweet, sweet. Comments or thoughts on that last one? All right, let me shut the recording down and then talk to you just a little bit more.